Hello, everyone, and welcome back to the final session of the day. We are absolutely delighted to have you. I think it's been a really interesting program so far. We started from Australia first thing in the morning, then Japan and Taiwan and Korea, and then the Middle East and Europe, and now we are on the East Coast. And there's been a slight change to the program. So instead of starting the program with a presentation by Reza from Vurio, we'll be starting with Najib from Two Photon Research. And Two Photon Research is a Canadian company, but he's actually joining us from New York City today. And this is a kind of a different topic. Nano-emitters, the end of the mass transfer is the title. And Najib has been starting high-tech companies since actually 1973 and has had multiple exits. And we're really looking forward to this, I think, unique contribution to the program. So Najib, when you're ready, please do start.
Thank you, Kasha. Hello, everyone, wherever you are. I hope you're well. And as as Kasha said in his introduction, one of the startups we did was making microleds, and we had figured out that microleds cannot make displays, which, of course, 8 years later has proven true. The struggle is still going on, but we did that for our own imaging purposes to use microleds with a built-in parabola for imaging. And that's the reason we sold that technology, and that is operating in Ireland. So I'm here to announce our new technology and commercially ready to go to fabrication of nano-emitters. And the presentation will follow uh, with explanation of what nano-emitters are, how they're made, what are the advantages, what is the fabrication process, and how have we made it possible to use molecular beam epitaxy in large uh, fabrication process for large volume. And I have to go to the next slide.
So Najib, you can see the two arrows probably on the top or the bottom of your frame, where it says 1 of 13.
Actually, I don't. That's bottom top of the frame.
Yeah.
Yes, got it. Okay, thank you. So I'll just move on to this. So nano emitters are nano devices, about 60 nanometers to 800 or 600 nanometers, and they are grown on sapphire wafers or quartz wafers or silicon wafers with about 3 microns of normal gallium nitride. These are commercially available, very low cost wafers. And then we grow in a molecular beam epitaxy pure woodside GaN crystals. These crystals have no discontinuities. Just as a reference, the continuities MOCVD produced thin film products have 10 to the 9 discontinuities per centimeter cube. We have none. There are no undesired doping. MOCVD is full of different chemicals, a chemical process. Ours is a pure physics process. And and those are the fundamental advantages. There's a mistake on my slides. Apologize for that. So that though no discontinuities, no undesired doping gives you higher IQE. So internal quantum efficiency is by nature higher. Therefore, we get higher EQE. And the biggest advantage of emitters is we can make all different wavelengths within the visible spectrum in one step, in one wafer, in one go. So you can make a complete display. The emitter part of the display is one step. And doesn't matter how many wavelengths or how many different wavelength nanometers are, it takes the same time. So now this is done by molecular beam epitaxy, something new to the LED industry, but we have been working on it for about 6 years almost from the beginning. The advantages are very simple. This is a process which is conducted in 10 to the minus 11 torr, about 10 to the minus 11 pressure of atmosphere. That's not actually correct in physics, but it's roughly right. So it's like operating in space.